Okay, one more piece that we need to cover today. Sorry, I forgot this earlier. And we're going to start out kind of just talking more conceptually. I don't know if that's really the word I want to use for it. But we have gone over a number already, pi. Okay? And pi was discovered by the Egyptians. During their experiments, they were having circles and they were comparing the measure of the distance across the circle with the distance around a circle, their circumference. And what they'd do is they'd have a piece of string, they'd stretch it across the circle, and then they would lay that string along the outer edges of the circle. And when they laid this string around the circle, they kept discovering that no matter what size the circle was, they could always lay 3 pieces of string down, and there'd be a little bit left over at the end that they couldn't quite make it around. And that's kind of how pi started getting developed. They knew it was 3 and a little bit more. Okay, so that's why we've eventually gotten that number to be 3.14. Okay, so just kind of a similar concept here. So we're going to look at an example of an exponential function. The exponential function is the example of compound interest. Okay, which says A equals your principal times 1 plus your rate divided by the number of times a year it is compounded to the n t power, where t represents your year. Okay? And they looked at this equation here, and they put a 1 just for the interest rate, and they looked at how you compounded it. So if I compounded it once, meaning yearly, I ended up getting the number 2 for my answer. Okay? And they continued to compound it more and more and more and more times a year. So it went to semi-annually, which was twice, quarterly, 4, monthly, 12, weekly, 52, daily, 365. And you guys will notice, especially down here at the bottom, all of these numbers started to become centralized around a number 2.71 approximately. Okay, so just like with the Egyptians, where they found this number that kept repeating over and over again, and it eventually went to the Romans, where I think they're the ones that actually gave it the symbol pi. I'm not 100% sure on that. I should probably check. But just like that, we're going to be dealing with another function, or there's another number that shows up a lot with these exponential functions, and we're going to use an e to represent that function. And that comes from your formula, which is, again, your principal, but instead of taking it times however many times it's compounded, they say this is compounded continuously. So it's constantly being compounded. And you're going to use this symbol E, which E represents something that is approximately 2.71. Okay? And you still take it, your rate times your time. So you don't need to memorize those two formulas. That's just kind of explaining how you can come up with this number E. Okay? Now, we're going to talk a little bit more about what E means for us here. So we have our new symbol E. It is approximately 2.71, and E is the base of what we call the natural exponential function. Okay, so that function would be y equals e to the x power. Okay, so again, if we're going to graph this thing, for an exponential function, we know our x's, -1, 0, and 1. Okay, so if we have a function here, I know I already said this, -1, 0, and 1. -1 goes with your reciprocal, which would just be 1 over e. You plug that in your calculator, figure it out. There's a button for e on your calculator. 0 goes with 1, and 1 goes with e. Okay, and you can see an example of this graph here, 1e, 0, 1, -1, and 1 over e. So this is approximately 2.71.
Attention, this is a reminder we have dropped everything in read this morning. Please make sure you have reading materials to your second block class.
Okay, now, since this is an exponential function, we know that it does have an inverse. It must have an inverse. So what's that inverse going to be? Well, remember the inverses for exponential function and logarithm functions, they have to have the same base. So the inverse would be a log base e of x. However, you will never, ever see it written like that. Okay? We call this our natural logarithm function, and it will always be written as ln of x. Okay? So log base e always will be written as this. Okay, so you're going to have to memorize ln x means the log base e. Okay? So, basically what we need to know about that is you can simplify with your natural logarithms. Remember your ln is log base e. Okay, so this here is the log base e of e squared. Now their bases match, correct? So, if their bases match, they should cancel. Your answer will be 2. However, I do not want you to show your work this way, okay? Because you will never see someone write that as a log base e. I'm just expecting you guys to know if you see an ln, because that's a log base e, those two things are going to cancel. Okay? So those two things cancel. I'm left with a 2. Same thing down here. I've now got an e to the ln of 3. So remember, this base is technically an e. These two things will cancel, and you're left with a final answer of 3. And that's all we have for today. If you guys have any questions, I'll be back tomorrow. So you guys can ask me then in the morning, 7:30.